The next question says, given this sawtooth waveform, apply it to this circuit down here and find what the output is. Find out what V naught of t is. So our first step is to find what our transfer function is for the circuit. So that's going to be, this is a voltage divider. The output is 1 over, the total impedance is 1 plus 1 over S, that's the capacitor, plus S, that's the inductor. Just to make it very clear, this is 1 over S, this is S. Getting this into standard form involves getting rid of this 1 over S subpart. So we multiply the top and bottom by S. S times 1 is S, and S times the bottom gives us S plus 1 plus S squared, and we'll put that into standard form in the bottom. Decreasing powers of S. Now we're going to create the table. We've got N, omega, and omega is just the same thing as N times our fundamental frequency. We want to find our corresponding Fourier coefficients. We want to know what our transfer function is doing at those times, at those frequencies, and then we can compute our output Fourier coefficients. And that, the output, it's just a phasor product of the input phasor times our transfer function evaluated at that frequency. So we'll start off with n equals 0. Omega is 0. I mean, it's 0 times omega naught. We said, remember, omega naught we found up here as 2 pi. Our a sub n for this, a sub 0 is always equal to c sub 0, and we found that already. That's equal to 1/2 in the top part. Our h of omega, well, this would be h of, here's our omega 0, so we're going to evaluate this at 0, and that gives us 0 over 1, which is 0. And that means that our output phasor, a sub 0 v sub 0, is going to be equal to the product of these two pieces, 1/2 times 0, which is 0. For n equals 1, for the first harmonic, we have 1 times the fundamental frequency, which is 2 pi from above, so we're talking about the 2 pi frequency. Now, just like for n equals 0, our a sub 0 is the same as c sub 0. For n greater than 0, our a sub n is equal to 2 times c sub 1. And we said up here, that's equal to j over 2 pi, so 2 times that would be equal to just simply j over pi. You could alternatively multiply this by 2. It's just faster to write j over pi. Now, h of omega is a little bit nasty to write. We've got to write this substituting j omega, where this is our omega. So that would be j times 2 pi. 2 pi is our omega, and that's our numerator. And then over that, we're going to have to divide that by j 2 pi squared, first term, plus j 2 pi, second term, plus 1. Luckily, our calculators handle all of it. We just plug this in, multiply it by this, and out pops 0.0513 at an angle of 9.27 degrees. Let's get that second harmonic in there. Hope we have room. Our omega is 2 times our fundamental frequency. Since our fundamental frequency is 2 pi, that's 4 pi. Our a sub n is now 2 times c2. We said our c2 is equal to j over 4 pi, so this will be equal to 2 of that, or j over 2 pi. And I don't know if we do have enough room to write this. That's our numerator. And then our denominator is going to be that squared plus j4 pi plus 1. Throw that into your calculator, and now it comes 0.0127 at an angle of 4.58 degrees. And now you can reassemble all these parts into the answer. V of t, the DC plus the first 2 harmonics, is equal to 0, the DC component, plus the first harmonic at its corresponding frequency, plus this amount of the second harmonic. Notice, like you'd expect, it's smaller magnitude than the first harmonic. And the whole thing is in volts. Notice how easy your life was by creating this table. It also makes it a lot easier for me to grade.